Hello, attendees. Welcome to Boston Review 2021. The event will be starting in a few minutes. I think we can just wait for a minute so that people can join, and then we'll start the session. Okay, I think we can start the session. It's time. So, a very happy morning in India, but you'll be in different time zones. It'll be great. It is great to see you all. Happy New Year to all of you. So, I'm so excited to welcome you all to the Boston Review 2021. This is a start an important event series in NeuroTechX. So, I'm Karthik, the chapter lead at NTX India. So, this event is all about the discussions and the advancements of neurotechnology in 2020, in spite of a tough year and a lot of challenges that we have faced in 2020. But neurotechnology has seen a tremendous growth in the past year. So we are all here to have a discussion about the growth and advancements and also network with each other. Yeah. So the Buzz Review 2021 series is one of the flagship event series of NeuroTechX. So this series actually goes from Jan 20 to February 4. There are a lot of chapters hosting this event. So you are in NTX India, Australia event, but there are a lot of chapters organizing this event till February 4. So even if you miss or if any of your friends miss the event today, you can always join the other chapters event to get a gist of the advancements of neurotechnology. Yeah. So as you all know, NeuroTechX is the largest international community for neurotechnology enthusiasts. So it's around for the past 5 years, and the number of members in NeuroTechX has crossed 5,000. So it's a very interactive community, and there's also around a lot of chapters all over the world. So can you share? Yeah. So as I said, our mission of NeuroTechX is to facilitate the advancement of neurotechnology around the globe. So today, India and Australia has collaborated to bring you this wonderful event where we're focused. So NTX India and Australia, new chapters we have started in the end of around 2020. So NTX India has hosted four to five events. And Australia has hosted one event. So we're completely focused on bringing up the advancement of neurotechnology in our countries and also the world. So NeuroTechX has three major pillars in which it is trying to achieve its mission. One is the community, where there's a huge community, global community of experts, entrepreneurs, and enthusiasts. Majorly, we have a Slack channel where this is the main part of the communication. And also, NeuroTechX provides accessible resources and learning opportunities for beginners to experts. You can always visit the neurotechx.com to get access to all those resources. And one of the key components of NeuroTechX is the innovation community, where there are a lot of innovations and problems that needs to be addressed by neurotechnology, and neurotechnology is going to be the near future. There's a lot of advancements happening right now. So innovation is one of the key component pillars of NeuroTechX. So there are around 16,000 plus community members, 13 volunteer-led activities, and every year there are around 200 plus global events. And currently the chapters are really increasing at a rapid rate. We have around 25 plus chapters worldwide. So yeah, this NTX would like to happily present you the Buzz and Review 2021 flagship event series of this month. So it's a great opportunity for all of us to interact, discuss the latest advancements of neurotechnology, and I'm so excited for the session. Yes, so we would like to enter the major components of the session, starting with the big trends of what has happened in 2020 in the field of neurotechnology. So I'd like to introduce Andy, who is the chapter lead at NeuroTechX Australia, to get started with the session. Thanks.
Thanks very much, Karthik. And welcome to everyone from Australia, India, from anywhere around the world that you are tuning in. This is very exciting. As you mentioned, India and Australia are new chapters. Have only a couple of events in Australia so far. So really excited to have this. And for everyone who's interested, I'm going to talk about a few minutes about all the big trends that happened last year in neurotechnology, and especially the field of brain-computer interfaces, because a lot of the news we're going to share are in that area, which is very exciting for myself because my research is also in that area. If you move on to the first slide, the first company we're going to talk about is Kernel. And for those of you who don't know, Kernel is actually a neurotechnology company in Los Angeles, California. It was founded by Brian Johnson. You can see actually in the first top picture, they're wearing one of their BCI caps. So the field of BCI is all about connecting brains and computers. And the first step is studying the brain, understanding the brain. And there are different ways of reading signals from the brain. It could be invasive method or non-invasive method. Invasive methods are where there's usually a surgery, whether it's minimal or not. These guys at Kernel, they're focusing on non-invasive method, which are they don't require surgery. As you can see in these pictures, they're usually some form of caps that you put on your head. And in that area of non-invasive, usually methods are either based on electrical or magnetic activity of the brain, or they're based on proxies that will show us how the brain is working. And those proxies, the best one so far is the oxygen levels around the vessels that are covering the brain. So kind of by looking at the blood activity and the oxygen levels in the blood, kind of proxy that as brain activity. So there are different kind of devices that are doing the electric, the magnetic, or the blood flow. And these guys have been working on a couple of them in the last year. So following the news, they are doing two big products. One of them is Flux, which is actually a magnetic device. And the other one is Flow, which is looking at those that the blood activity that I mentioned. The technology is TDF NIRS, so that's time domain near infrared spectroscopy. It's kind of like flowing. It's looking at the flow of oxygen by optical means, so by just showing some light to it and then seeing the reflection, and based on that working out how much oxygen is in the blood. It's a very exciting thing, and MRIs and those kind of devices are kind of working on the similar principle. The other thing is the flux, and also another exciting thing is on the business side of things, where they are offering now what is called, or they call it, neuroscience as a service, which is a model of providing paying clients access to its imaging devices. And that shows that there is new traction to these kind of devices. They are just getting outside of the research ecosystem and into the commercial ecosystem, which is fantastic news for people who are really interested in this area. I think the company is now backed by Brian Johnson himself, who used to be a venture capitalist, and by other investments there. So now they've raised $53 million in Series C. If you move on to the next bit of news, Synchron. For us in Australia, this is a proud moment. Synchron is an Australian company. They started at the University of Melbourne, and in the same kind of research group that we are working in. And Farhad will talk more about that in the next session, where he's talking about research. They have had some government funding in the past and into grants that they have won. Centrode is designed to, Centrode is the device designed by Synchron. And it's a device designed to function as both a neuroprosthesis and a neuromodulation device. It's implanted next to the brain's motor cortex, but the way it's implanted is the innovation. So it's implanted in the blood system rather than going directly on the brain, as most of the brain computer interfaces devices do. It interacts with the nervous system from inside the blood vessel. In December 2019 or thereabouts, the first successful clinical implementation of that took place. Around July, Synchron secured further funding from the Australian government for about $1 million Aussie dollars. And this is on top of the NHMRC grant that the University of Melbourne got a bit before that. The year before that, they finished up their animal testings in sheep, and it was promising. So they moved on into human trials. So the first in-human trials of the device was done on, I think, 2 ALS patients who were implanted with the Centrode PCI system via the jugular vein. So there is a little bit of surgery. It's not as invasive. So we call it semi-invasive. So it's not open brain surgery. That's the point of it. And the ALS patients were successfully controlling a personal computer through just thinking about things. And that's just fantastic news for people who are following this. It's a big success for the founders of Synchron, and with that bit of funding, they're now moving into more clinical trials in the next year. Cool. So a couple of other news with the other companies that you might or might not be following up. Some of this is very new. So University of Michigan is giving amputees new intuitive control of the most advanced robotic hands on the market. Their new approach centers on regenerative peripheral nerve interface, or RPNI, where a small graft of muscle tissue is surgically attached to the end of this severed nerve in an amputee's arm. So this is very different to what the other system we were talking about in the ALS patients, where there's really zero muscle control, or actually just voluntary muscle control. So here there is something, and it's kind of the general approach of the BCI. Wherever there is a possible use of the muscles, that's always preferred over the fully BCI version, because there's obviously still limitations in the full BCI version of devices. Another piece of story on the news was about Ian Davis, who lost 4 of his fingers on his left hand in a work accident. His insurance did not cover the prosthetics. For some reason, I believe this is probably US. He was also diagnosed with a form of cancer, multiple myeloma. which is an aggressive type of cancer, but he decided to kind of build his own mechanical prosthetics. And he claims that he's working better than the electronic ones, and that made a bit of news last year. Another company that is a startup, Atom Limbs, they're in the middle of raising their next round. Again, in the field of BCI, but more interested in realistic robotic arms and bringing feeling back. So even trying to simulate the feeling of touch in the robotic hands through their devices. The last bit of news is about Tesla Suit, which was founded in 2018 and releases enterprise and government Series XR training in the first quarter of 2019. So what they're doing is a human to digital interface designed to simulate experience and accelerate mastery in physical world. So I believe they've gone into gaming a little bit as well, and they have a VR enabled system that can be used both for training and gaming, which are the two other big areas that BCI is now getting traction in, other than use as a medical device. And I think this is very interesting because gaming has always been open to new technologies like this, and they have always been a very good testing ground for all this type of new technology that will come out. So as long as things get out of the medical ecosystem, it seems that there's more traction for them in a commercial sense. Cool. I think, I will now hand over to the other co-founder of the Australian chapter, Farhad, who will talk about some of the big research news came out last year.
Yeah, thanks so much, Andy. I apologize that I cannot join with video. My internet is not stable enough. So I guess Andy really talked about kind of like, the technology that is now available. And when we really say available, it's like, it is now become a lot more accessible. But what I'm going to talk about is more on the research side. So this is everything that I'm talking about right now. This is only happening in the labs inside the universities. So this is hopefully something that would come out of universities in the next 5 or 10 years. So if you can, so the first one is actually, this is very interesting. This came out last March. So this is a paper in Nature that was published, and it talks about the possibility of using epidermal electrodes. So these are the electrodes that can just go under skin. The good thing about these is that they're very comfortable. It would be a very easy surgery for anyone to do it. So even a GP can put these electrodes and they can bring them out at any point, which makes it super useful. So if anything happens to them, you can easily take them out, because a lot of the brain implants, one of the biggest problems with them is that once they're implanted, it would be really hard if anything happens to them if you want to take them out. So the research that was done on these electrodes was that it was shown that these implanted on the under skin electrodes, they can record EEG, but more importantly, they're also safe if you're around a magnetic field. So that is very important. And as I said, this would make it super easy to create different implanted electronics. So if we go to the next one, so this is another very exciting research. This is the possibility of actually printing electronics on a skin. So you probably have heard about printed electronics, which is a really big and new field. And it's a very up and coming field in electronics. So this is now putting these electronics on the skin. And as you can see, this would be even taking everything one step further. In the research that was published, this is just like, the researchers just printed something on someone's skin, and it could measure very simple things. I think it was able to measure the temperature from what I remember. But you can imagine that moving forward, if this becomes a bit more accessible, then we can think about recording other biosignals other than just the temperature of the skin. So this is also very useful because we would go even one step further and can only print things on someone's skin that it can easily be peeled off. The other very interesting research that is happening, this is the one that is happening at the Baylor College. So this is in Houston. And what they did is that using some implanted electrodes in the vision cortex, which is just at the back of your head, they were able to stimulate that part of the brain, and the person who is blind can now see traces. So this is a really interesting way of communicating information to someone's brain. So this is more of like a direct communication with someone's brain. And as you can imagine, this would have a lot of applications in the future. So what they did in this research, that they showed that the patient who is blind can actually see some of the traces that the device helped them stimulate. One of the very interesting things, in my opinion, that happened last year was, if you go to the next slide, is the work that was done. This is the nerve rehabilitation. This is probably the closest thing to become something that would be available to patients very soon. So both University of Pittsburgh and the EPFL Lausanne University Hospital, they are both working on this. So there are a lot of nerve stimulators in the market already. These nerve stimulators are generally used to reduce the pain for patients who are suffering from a lot of chronic pain. But the researchers were able to use the same nerve stimulators and kind of bypass some of the damaged nerve in the spinal cord. So what this means is that, so if you actually, if you go and search this, you can see that mouse on the bottom section. There's a video of that mouse. So that mouse had the spinal cord was actually cut. And so he wasn't able to move his legs. But then they used these implanted nerve stimulators, which bypass that bit of the broken nerve. And then the mouse actually learned how to use it. So he was able to walk again, which is amazing. And it could be used for a lot of people who have lost the ability to walk or the ability to control any of their, any part of their body. Now we can think about using these nerve stimulators that are already available, and they already have passed all the regulations, so we can kind of use them as another application. And the fascinating thing for me is that your brain can learn how to use this new device that it wasn't able to interact with, and the brain can interact with this device and uses it to then control your muscles. And the last bit that I would like to talk about is this new research. This is from the Monash University, again in Australia. So another moment for the Australians to be proud of. So this is again very similar to the vision stimulator that we talked before. This is a new device that was developed here at Monash University. And again, it can read the information from a camera, but directly stimulate your vision cortex at the back of your head. And it would give the patients who cannot see the ability to have sight again. I think that's all I've got to talk about today. And we're coming up to a break. So if you have any questions, please feel free to put them in the chat area.
Yep. So thank you so much for that. That was very interesting. So I'd like, so before going to a short break, I'd like Kali to run through the regulatory approvals that have been in the past year, that have been approved in the past years of the companies and their products. Kali, can you take it forward?
Yeah, sure. Thanks, Karthik. I'll go through. Hi, guys. Thanks, Fahad, for the very brief about the tech news. Next, research news. Then next we'll be have a go. In spite of the COVID situation prevailing here, we'll be now going through the some of the companies which have achieved their milestones of getting FDA approvals, and one of them are first we are going about NeuroElectrics. NeuroElectrics is a company which has developed a novel platform to provide personalized therapies for brain disorders using non-invasive brain stimulation. As shown in the picture over here, they have developed a brain stimulation which are help through patients with major depressive disorder, and thus these therapies are used are non-invasive brain stimulation. Next slide, please. Here comes the next one, actually, which announces the FDA clearance of uh, Endervex product, which mainly focus on children with ADHD. Their person is to deliver a video game which can overcome this ADHD deficiency and hence improve the. Next slide, please. Here comes the next about PC neurostimulator. These PCD brain stimulator systems developed a neurostimulation system with the ability to chronically capture and record brain signals while delivering therapy to patients with neurologic disorders, like diseases like Parkinson, essential tremor, dystonia, epilepsy, or obsessive compulsive disorder (OCDs). This product can uh, track brain signals and correlate these patient recorded actions or experience such as symptoms, side effects, or meditation intakes. This enables more personalized data-driven neurostimulation treatment. Next slide, please. Here comes about. About has developed the iOS app for managing the chronic pain and movement disorders. It was intended to execute a controlled US market release in early 2020. This company's third FDA cleared indication for its deep TMS system and its first FDA clearance in the addiction space for TMS device. Habitet's regulatory approval may facilitate progress. Hello? Yeah.
That's audible.
Yeah, am I audible?
Yes, you're audible.
Okay. The slides are changing, it seems.
Are you on the about slide?
Yeah, I didn't. Next slide, please. About I have done. Next about BrainsWay. Yeah, got it. Next comes about BrainsWay. The BrainsWay has developed.
I think you have a problem with an internet.
No.
Yeah.
Am I audible now? Yeah. Yeah,
Yes,
please.
yes. Go ahead.
Yeah, it has developed a control.
Hello? Is it? I think. Yes.
It has developed the first FDA clearance in the addiction space for TMS device. Third, approval for BrainsWay following the clearance of H1 coil for patients suffering from major depressive disorder and H7 coils as injector treatment as shown in the figure. This device just aims to create this device aims to just control control the control and sense the brain signals for further process and applications. Next slide, please. Next one, we go for prosthetic arm and slant array, where they have this haptics regulatory approval may uh, facilitate the progress and approvals of slant arrays for other peripheral nervous system uses that are already being explored experimentally, such as for auditory nerve implants to provide improved hearing and motor nerve simulations. For reinventing paralyzed limbs after spinal cord injury or stroke or bladder control or pain mitigations. Next slide, please. This comes about NeuroAim. NeuroAim is a company that breakthrough the device designation of bioengineered head device shown to reverse Alzheimer's memory loss in its pilot study published in the fall a journal of Alzheimer's disease. No other drug or device has received the highest FDA designation to accelerate the treatment of Alzheimer's disease. No, this has demonstrated the clinical results we have thus far not only show but in fact reverse the progressive, debilitating loss of memory caused by the devastating brain disease. It's a statement about the CEO of NeuroAim Therapeutics. Next slide, please. This talks about the famous G healthcare company, which they have announced clearance of Signa 7.0T magnetic resonance imaging MRI scanner, the world's most powerful FDA cleared MRI device available, with a magnet approximately 5 times more powerful than most clinical systems available in the market. It function metabolism. It captures image anatomy, function, metabolism, and microvalve structure in the brain, and joins with the incredible resolution and details. It provides a unique platform for advanced knee and cartilage imaging, allowing for ultra-high resolution anatomical visualization as well as research capabilities to measure quantitative changes in anatomy due to disease. I think that's it from my side for about the FDA approvals. Over to you, Karthik.
Okay, thank you so much, Kali. So as he said, there are a lot of companies, in spite of difficulties, a lot of companies have got FDA clearance for their wonderful products. So let's take a short break. But there are a lot of interesting sessions after the break. We are going to have our advisor of NTX India, Suhela, talking about tech innovations and tech funding that has happened, and also about the competitions and NTX activities. And at the end of the session, we are going to have the wonderful opportunity of networking with each other. There is also we have also had Morgan, who is a very expert in the field from San Francisco. There are a lot of people like Brian and Mohit are there. So it's a very wonderful opportunity to network, and the networking is going to be very interesting. It's not a sort of a normal networking. So I'd suggest you to take a short break, 5 minutes break, and just get back to the sessions very soon. So yeah, now it's break. You can go for break. Thanks. We'll be starting in Indian time. It's around 12 to 11:15. Yeah, 11. We'll start around 11:15. Yeah, thanks. Yeah, I think it's 11:15. It's more than 5 minutes, so I think we can go ahead with the sessions. I hope you all had a good break. So, starting this session with Tech Innovations by Suhaila, advisor at NTX India. So, over to you, Suhaila, for an interesting session. Yeah.
Thanks so much, Karthik. Hi, everybody. It's so good being here today. A very, very happy new year. Like greetings to, all of you there. I'm Suhaila Kapoor. I'm the advisor to NeuroTechX India. And I think we can all agree to say that, 2020 was a rather hard year for all of us. So I hope you all stayed safe. But, despite all that, a lot of tech companies, continued with their very hard research and development efforts and could translate them into some, great practical applications, which we are going to be now discussing here forth. So why don't we start off with that? I'll take you through the fantastic tech, innovations which happened across the whole year. So we did see a huge leap in both invasive and also non-invasive consumer neuroimaging with Zeto's first FDA approved wireless EEG, which actually can be used for all routine and urgent EEGs also almost anytime, anywhere. This is the first device you see on your screen here. And it doesn't need a trained expert. So I think it'll be fantastic in a lot of low served, settings across the whole world where we may not have a trained expert really. Then we had, GTEx Pangolin, which actually has been a great amalgam of both tech and art and also aesthetics. It is the first ultra high density wet electrode grid with, I think, more than about 1024 channels for recording. So it does measure, it does measure several parameters such as EEG, EMG, and many other body signals. GTEx Pangolin is the one on the absolute right hand side. I hope you can all see that. We also had, Neurocity's Notion, which is actually regarded as the first brain reading computer. It has been launched as a powerful headset tool, which can, which has this inbuilt CPU and, a RAM. So it's almost got a computer inside it actually. Connected to several sensors and powerful machine learning tools inbuilt in this whole suite. It seems to have some really good exciting applications for people who do require assisted mobility, such as those those paralyzed individuals who probably cannot use wheelchairs because they don't even have enough ability left in them to be able to utilize these. We also had OpenBCI's Galia. It's the next gen mixed reality platform. So it does combine AR and VR both. It actually integrates EEG, EMG, EDA, and PPG, and also eye tracking into a single a single basket. So it's a very comprehensive tool which has been launched by the OpenBCI people after a lot of years of hard work and research and listening into what all the neurotech users have been asking them for. Now in the category of simulation and modulation devices, so the devices which can be used to actually stimulate the brain and modulate brain activities, we had Neo Rhythm, which is the first gesture control headband. It was launched by Omni PEMF. It's proven to be very effective for sleep, relaxation, attention enhancement, and helping people manage pain. So for those users who cannot, who probably are suffering from extreme pain, Neo Rhythm has been found to be extremely beneficial. Fieldmore Labs launched Cove, which helps with modulating stress by applying gentle vibrations behind the ear on the mastoid and on the temporal bone. So again, extremely beneficial neuromodulation device. We also had NeuroFuzz Pro, which is the first attempt to apply transcranial pulsed ultrasound to the human brain. It is similar to TMS, but because of using ultrasound, it can actually reach much deeper brain areas and can achieve much higher spatial resolution also. Moving on to the second slide in my section, please, Santi. Thanks. Paradromics, whom we've all heard of a lot, showcased their first ever recording of the cortex using more than 30,000 electrodes. It's in the sheep cortex, So this is all now, like invasive imaging. It's been it seems to hold a great boon for patients with, paralysis and several other like disabilities also. These are all wet electrodes which have been actually used in the sheep cortex. Can we move to the next slide, please? I think we all heard like Neuralink's presentation, a presentation Elon Musk took us through. The very exciting three sheeps, Joyce, Dorothy, and Gertrude. This pig was made to walk on a treadmill, and they could actually trace back the activity back into the brain. This is again invasive imaging. The idea is to move to, so really the idea behind, I think, Neuralink is to move towards more AI symbiosis, which merges the brain with artificial intelligence. It aims at suggesting clinical applications again for individuals with like disabilities such as stroke, paralysis, etc. Just to highlight, Neuralink used about 1,024 channels in their surgically implanted device. Moving on to the next slide. University College of London launched their first wearable cap, which takes 3D images of babies' brains. It's been really hard to actually scan babies' brains because, until unless you do anesthetize these small children, they would keep on moving. So MRI has proven to be very difficult in very young children. So UCL's, wearable cap actually takes 3D images using high density diffuse optical tomography while a child is actually awake and walking. This so this has also this is also posing a lot of opportunity to start imaging children's brains, especially those suffering from various like neurodevelopmental disorders, and to start scanning these kids early on to be able to diagnose and detect what sort of anomalies there might be, and start bringing in intervention a lot earlier on. Just like MRI high dot also sees the oxygenation changes in the child's brain. Okay, moving on to tech funding now. So well, nothing happens without money, and money makes business go, but I think it also is required for also R&D. So again, there was some fantastic funding initiatives which actually took a lot of these R&D efforts into actual culmination. So in February, we saw 63 backers pledged more than 5,209 euros, which was a fairly large sum to support the Make 100 project, which is actually aimed to facilitate developers to build their own BCI apps. I think we all are looking for such kind of funders, and it's really fantastic when such people come together to actually support such sort of initiatives. In March, we saw Happy, which was funded for almost 551,000 US dollars by a crowdfunding effort. So there were 1,283 backers. They launched their first wearable that helps users stay and feel calm. So it's one of the most effective substance-free mood-altering tools. And in October, we saw Bring Bionics, who started on their journey towards the Impulse neurocontroller for personal computer gaming. They were funded 55,000 Canadian dollars, which helped bring this whole project to life. 306 backers supported them. Moving on to the next slide. In October, we saw Rune Labs, who actually closed a 5 million seed round. Rune Labs takes brain imaging and electrophys data generated during clinical trials and patient care, and uses this data for further neuroscience therapeutics. They are particularly focused on DBS and on TMS. So both of these techniques are both non-invasive, and they can help provide very high resolution, spatial and temporal, both actually. And they really focus towards moving, offering personalized precision medicine to their various users for again modulating users to help with their movement control actually. Moving on. So in July, Maxtem acquired electrical geodesic whole product portfolio. Their high density EEG actually complements Maxtem's TMS technology, and thus provides a whole closed loop suite for non-invasive neuromodulation. So both Maxtem and now Geodesic have a very, very comprehensive suite for looking at the whole non-invasive side of like understanding what's happening within the like brain and being able to stimulate and modulate it. Moving on. Okay, Neurovalence actually received fresh funding of 5 million pounds to expand its various ongoing clinical trials using medical devices. So Neurovalence portfolio is basically focused towards weight loss and also insomnia. Their headset can stimulate the various parts of the brain that control diabetes, insomnia, anxiety, and also obesity, which are amongst the like leading conditions in the whole world. I think obesity is ranked as one of the highest the most common disorders. India has the highest number of like diabetics in the world, and both insomnia and anxiety contribute to several mental health conditions. So again, a very, very beneficial device, and I'm sure this funding will contribute a lot towards their hiring better engineers and going into a more operational mode. The company is looking to actually acquire their final approval for their trials within the next 12 months. Moving on comes Nia Therapeutics, which also raised 1.5 mil US dollars for their memory restoration device. This is an implantation and like implantable device in the brain, which helps with stimulating memory. Specifically helping people who have memory impairments. Again, targeting users in their older age who might be suffering dementia, Alzheimer's, or people who might have memory loss due to a stroke condition, hemorrhages, etc. and etc. And moving on to the final slide, we have Astellas, which actually acquired IOTA Biosciences. So this began with an R&D agreement which started in 2009, where they jointly agreed to use IOTA's ultrasonic powered bioelectronic device. This has now actually moved into becoming a merger where Astellas acquired IOTA Biosciences sometime this year, and they're moving towards developing Accelerate RX, which is for the exploration of various other applications using IOTA, as I just mentioned, using IOTA's bioelectric technology for new target diseases and for developing newer technologies. So they are actually building a very interesting platform where they will be developing implantable medical devices, and moving towards wireless communication using ultrasound tools. So that's pretty much it from my side. This has been fantastic. I would be really happy to have a conversation with you towards the end, where we have this open discussion forum, and I do invite you all to be there, and we can take few of these of these tech findings into a much deeper dive and see what's going on really. Thank you.
And, thank you, Sohaila. I think Santi could take over with the activities of the NTX community last year and the competitions that were held by NeuroTechX.
Yeah.
Santi?
Hello guys, this is Santi, the project lead at NTX India. So apologies because I can't switch on my video because of bandwidth issues. Yes. Moving on. So what a great set of technological improvements this year, right? But we also know that there is no progress until there exists competition, of course, with monetary fundings. And I will walk you through the events and competitions conducted by NTX and other organizations that helped improve the knowledge among the public, right from the college students. Yeah, first up, we have the NeuroTechX Challenge conducted by our own NTX in collaboration with Novella Neurotech. This was basically a competition of seizure prediction using the existing world's largest publicly available dataset of clinical EEG recordings collected by Temple University Hospital for around 15 years. This was a month-long challenge, and it's an interesting open challenge to solve, which has been not solved yet, as in, yeah. Next up, we have the first developer challenge by Neosensory with the usage of their product called Buzz. Let me give a good context about the Buzz. Buzz is basically a wearable watch-like technology that has the capability of translating stimuli into various patterns of vibration using the four motors in their wearable, which can independently produce 255 levels of vibration. So Buzz works by the principle that our brain learns information by correlating the relationship between different senses. So this challenge was not a fixed challenge, but an open challenge where teams are asked to fix on a problem statement that they want to solve using Buzz and this particular property of the brain. There were remarkable projects that were developed in the challenge, like air quality sensor in integration with Buzz, emotion recognition as an aid for people with autism spectrum. Next up, we have the college students exclusive, our own NTX student club competitions 2020. We had two categories in this competitions. One is the open challenge, the other one is the fixed challenge. As part of the open challenge, you could choose a creative problem to solve using neurotechnology. That is, you propose an idea, give a demo, and then you go on to build the technology. We had creative projects that were built as part of this, like a keyboard that is operated out of EMG, that is electrodes fixed onto the arms that can predict the movements of fingers. And then another one is an automated, cheaper, and a more accessible way for sleep scoring. And as part of the fixed challenge, students were asked to build a fully homemade acquisition of EEG signals and visualization of it. So this is challenging, isn't it? Next up, we have also had an amazing initiative by BitBrain of a grant competitions to projects that explore the topics of human behavior research and research around brain-computer interfaces. Next, we have had Cybathlon conducted. So Cybathlon is basically an initiative that started in 2013 to drive the development of technical assistance systems for everyday use and promotion of inclusivity of people with disabilities. And this year, there were more than 50 teams from various established disciplines participated, and it was a great success. Yeah, so not bad for a year affected by the pandemic, right? For the upcoming years, the growth of this community will definitely be exponential. And I assure you that more of such interesting events are around the corner. Yeah, thank you. And then over to you, Karthik.
Yes, okay. So yeah, thank you so much, Santi. So Suhaila talked about tech innovations and tech funding that happened. So there was a lot of tech innovations and interesting innovations, which clearly visualizes the future of neurotechnology and brain-computer interfaces. You know, when we think of brain-computer interfaces, we're able to think of what kind of applications we have. It can be applied in almost every field out there possible, since we're getting the brain data. So it comes with along data privacy and ethics, but there are policies that are being framed in the start in the US, and policies will be framed with concern with the data privacy and data security of brain-computer interfaces. So with respect to competitions, actually, I have a personal touch. When I got introduced to the field of brain-computer interfaces around 5 to 6 years ago, I didn't hear about NeuroTechX. The one thing that attracted is the drone racing using EEG. That was happening at the University of Washington Center for Neurotechnology. That was one thing that really inspired me to enter in this field of neurotechnology. So there have been a lot of events and community efforts that has been coming up with NTX, and even in India and Australia. So we've started, and there's a lot of plans that we have for the next year, 2021, in both India and Australia. So kindly watch out. So with respect to the NTX community efforts, there are a lot of initiatives that have been taken in the year of 2020. So one thing is the NTX diversity initiative. You can always check out in neurotechx.com that has all the information regarding with the initiatives. This is mainly to address the issue of diversity and inclusion within NeuroTechX and the field at large. So if you want to join this initiative, kindly connect with NTX Slack community at #diversity channel. Yes, next slide, Santi. Yes. So with respect to AEG Notebooks, AEG Notebooks is one of the interesting initiatives taken by NeuroTechX community. Actually, it began a number of years ago to majorly to play around with the data from the new Muse EEG device by Alexandra. So what AEG Notebooks is basically to let you run cognitive neuroscience experiments on your laptop or computer. So the library has AEG Notebooks is being built by NTX community members, but we also have one member right here in the meetup, Morgan. So he is one of the major contributor and in NeuroTechX and also in this. So interested people can check out the GitHub link for EEG notebooks and get introduced to yourself in the discussion section. Yeah, next slide. Yeah, Moab. So Moab is one of the interesting initiatives too. So the Moab is basically to build a comprehensive benchmark of popular BCI algorithms, because there are a lot of publications out there, but not so much algorithms are open source. So I kindly strongly suggest you and strongly to check out Moab, the GitHub links. And if you want to, they're also looking for developers and collaborators for developing this Moab platform. So kindly check out the GitHub link or get out in and take Slack if you want to get involved in this. Yes, next slide, please. Yeah, the content laboratory is also one of the interesting initiatives in NTX. So actually, all these things happened kickstarted in 2020. Content laboratory is they're trying to create a lot of original content, and they're also planning to release a book in 2021. So if you're interested in content writing and want to learn more about neurotechnology, there's one great platform where you can learn and show your content to a lot of people. So I strongly suggest you, if you're interested in content writing, so contact Content Laboratory. So everybody is present in Slack community, so it's the best way to contact. So these are the initiatives that happened in NTX 2020 community, NTX 2020. So started with the BAR 2020, which happened at the start of January. And there are a lot of initiatives like IEEE, Brian Neurotech Workshop, Entrepreneurs Workshop, Neurotech Epilepsy, Neurotech Gaming Conference, and NTX India's Neurotrend Conference. So if you see NTX chapter activity in 2020, there are a lot of things that happened. And India has also conducted. So we started around August, and we had successful 5 events conducted at the end of 2020, and we have a lot of interesting events planned for 2021. So we are so happy that the NTX community is very effective in conducting events, and it's going to be very interesting to be a part of NTX. Yes, next slide, please. Yeah, so I'd like to tell one point that, so please check out, if you aren't yet in NTX or Slack community, please check out neurotechx.com, join the Slack community so that you'll get exposed to a lot of things. So with respect to certain extra informations that happen in the field of neurotechnology, I'd like to go with 2 extra informations that you might not have heard or you might have heard. So one thing is the WIS Center's real-time neural signal processing platform. So majorly, they have created a software platform called NeuroKey. It is one single software EEG and brain signal acquisition and analysis platform, which can get integrated with many other hardware device possible, because in terms of research scientists to do data analysis, they try to work and create their own software application. But because of this, there are a lot of data analysis that can be done in a single software, which can get integrated with a lot of hardware. So this is one interesting innovation that happened in 2020 August. Yes, next slide, please. So yeah, so as we've already seen Neuralink entering the field of neurotechnology, Elon Musk entering the field of neurotechnology, Brian Johnson, Facebook has entered the field of neurotechnology. It has recently, I think last year, it has bought CTRL Labs, working on brain computer interfaces and communication using brain. And again, Google has entered in one of the interesting projects called Google Amber. So this is a project, Google's EEG hardware device and software majorly to work on mental health problems. They wanted to solve this problem. They've entered into the field of neurotechnology. So we are able to clearly see the initiatives that has been taken. In the past 10 years, there have been a lot of research and a lot of companies, including big companies, entering in the field of neurotechnology. So this is one interesting time where we are all together to move ahead in the field of neurotechnology. Yes, next slide. Yes, this one interesting point that happened in 2020. So NeuroTechX celebrated our 5-year anniversary because it was started in 2015 by 2 members in Canada, just as a very small gathering to discuss neurotechnology. But now it has grown into a lot of chapters. So it's really a great honor for us to be a part of NeuroTechX because we're learning and exploring the field from wherever we are right now. So that's one of the interesting moments that happened in 2020 for us. It's a 5-year anniversary. Yes. So I think we've come to the end of the session, but not the networking session. That's separate, another interesting session. We've come to the end of the session. So surely let's stay in touch. So every country has, every chapter has their own meetup groups where they'll be posting events and updates. So kindly get updated in meetup and also join Slack. So even in Slack, every chapter has its own Slack channel. So you can join, if you are in India, you can join #India, or Australia, you can join the Australian channel. So kindly visit the website, neurotechx.com, to get all the updates and that is happening in NeuroTechX. So thank you. And now, if you have any questions with to the speakers, you can ask, or else, I'll ask Mohit to say the information about the networking session. Yeah, so Mohit, do you want to jump in right now? So, or else we can have the questions and interaction, everything in the networking session. Or Brian? Yes, yeah.
Hi, Kartik. Yes, I'll jump in.
Yeah.
And first off, I'll say thank you to all of our wonderful speakers today, but also to those attendees joining us from all over the world. Very much appreciate your interest in NeuroTechX, of course, but also just in neurotechnology as a field. There's a lot of potential here, and it's so great for all of us to be able to touch base and to learn together about all of the amazing things happening in neurotechnology in the last year, of course, but then also looking into the future, which is why I'd love to welcome everyone to join us to network together and chat about the things in neurotech that the future holds. We're going to host a networking session in Gather Town. So a link will be shared with a password into the chat in Zoom. You'll be able to click that link and it'll navigate you to a web browser page. And you should be able to see my screen now. I got a thumbs up from Kartik if that's the case. Wonderful.
Yes.
And you'll be able to launch Gather Town. There will be a NeuroTechX space that you've been invited to. It is password protected, but again, we will share the password in the chat window. And then once you join, you will see we have this virtual environment, basically, that we can explore, walk around, play around in, bump into each other, and have some casual conversations about brain technology. So we'll have somebody here at the NTX help desk, just in case you have any questions at all about NTX or about the environment in GatherTown. You can find individuals you'd like to have conversations with and join this private space or other private spaces that are marked on the floor here. There are a few others around the space, and you can see many more through in the main hall here. We do have some information as well posted around the space. And I have a nice map for you here just to be able to landmark within the space in case you get lost these days. It's easy to do when we're not leaving our houses much. We also have some exhibitor videos set up, information from folks at Synchron about their Stentro device. We also have information from NeuroTechX, OpenBCI, Neurable, and many more. So I'd encourage you strongly to be on networking with everybody within the space. Also, just take a look at what we have placed around the space, read up on it, learn more, and of course, then go on and bump into somebody else and just carry on the conversations. And then beyond that, of course, please do look up NeuroTechX Australia, NeuroTechX India as they grow their communities over this next year and into many years in the future. So with that, I'm going to turn it back over to Kartik, and I hope to see you in GatherTown. Thanks, everyone.
Thank you. Thank you so much, Brian. Yeah, I think the GatherTown link has been posted and also the password. Let's network in GatherTown. I suggest all of you to enter the link and get into GatherTown. Yeah, thank you. Thank you so much. Mohit, are we continuing in Zoom or shall we get into GatherTown directly?
We'll keep the Zoom running in case anybody has issues with GatherTown.
Sure. Okay.
We'll close it down.
Sure. Okay. Great. Yes. Thanks.